All right, let's look at the development of low mass stars versus high mass stars. So the low mass stars, they can fuse elements up to carbon and a little bit of oxygen. And that's because the pressures that are pushing down and the temperatures at the core are high enough that they can fuse helium into carbon and oxygen using the triple alpha process. But it's not hot enough, it never gets hot enough to fuse the carbon into anything else. So you end up with just a core made of carbon and oxygen. And once all of the other things have been converted to that, that's pretty much where you're going to stop. So there's just not enough temperature and pressure to fuse beyond carbon and oxygen. However, if we look at a higher mass star, then you'll see that you can get hotter and you can fuse even carbon and oxygen into other elements. This process is called nucleosynthesis, and it's where all of these heavier elements eventually come from. So in a large, heavy star here, much more massive than the sun, say, 3, 4, 5, 10 times masser, more massive, sorry, you still have that little hydrogen envelope on the outside, and then you have hydrogen and helium fusing, and those are fusing into helium. Then you have helium, a layer of helium that is fusing into carbon and oxygen. And then it actually gets hot enough that carbon and oxygen are going to be able to fuse to make things like magnesium and neon and more oxygen, which are going to fuse into silicon and sulfur. And ultimately, the end product is going to be iron. So the core of this is going to be made of iron. And for reasons that we'll explain later, iron is the last stage here. You can't fuse anything, you can't fuse iron into anything else. And that's because up until this point, everything that you've fused has released energy. But if you're going to fuse iron, that's going to require energy. And so it's not going to produce any more energy. So the iron is just going to accumulate here in the core of the largest stars. And eventually, we'll see what happens at the death of those stars. But for now, this is where we're going to end up.